Hi folks, in the first video in this series I showed you how to connect collections with the populate command, and in this video I will add to the project GraphQL using GraphQL-compose, which is a library that allows us to auto-generate our types and also the resolvers. So let's get started. Here is the project as we left it in the first video. So we have to do some refactoring. We will take out all the model and schema definitions for Mongoose to a separate file called mongo.js. So I will just cut out these two includes, so I'll put them here. And then I will take out all these definitions here of company, department and employee, and we will just export an object with two functions. Init mongo will be first one. So we'll just put here the code I just copied from app.js, and I will also take out the connection to Mongo database. So we'll just have the Express app here. So I will put that as the first statement in init mongo to connect to the database. Then the schemas will be created, and we will not need these names here because they are just local variables in this function. And I will also create one function called m, which takes in a model name and returns mongoose model of that model name. So then we have our Mongo file ready. In the app we can also remove this use statement. Since we have the data in the database already, we'll just keep the one here, and so for later use, and I will remove this use. So now our app is getting pretty small. To add GraphQL, we use Apollo server, which is a one version of the GraphQL standard. We will use the Apollo server express in our example. So we have to do yarn add, and we have to add the Apollo Express, Apollo Server Express, and then we need the GraphQL. So we will add these two libraries, and then we will require them into our app.js here. So we have the Apollo server here and the GraphQL function for backticks commands that we will see later. We will have that at the top. We will need also HTTP in here, so we'll add that here at the top. And then we will import our two functions that we put into the Mongo.js, init mongo and m. And then we can initialize Mongo like this. And here I will get the department, employee and company to use later in the app. Now everything about GraphQL and Apollo server is explained in the documentation for Apollo GraphQL, it explains how to configure Apollo server like I'm doing now. So I'm not going to go into details about GraphQL or Apollo server, just how you will add that to your Mongoose project. So after we have required in Apollo Server Express and HTTP, we just need to change a little bit here. We don't need this command here longer, but we will create an instance of the Apollo server. It takes 2 parameters, or it takes actually more parameters, but the basic definition is with two parameters, the type defs and the resolvers. In the type defs you have all the type definitions, queries and mutations, and in the resolvers you have how you resolve these queries and mutations. Then we add our app, Express app, as a middleware to our Apollo server. We create an HTTP server that listens on port 3040, and it shows us the GraphQL path for the REST endpoint and for the web service endpoint, because GraphQL also supports sockets, so that is very important functionality of GraphQL actually. So we can do yarn start then, hopefully, and it is listening on port 3050. Yeah, it's because I didn't save the file, so I will save it now and try once more. So we get an error here because types and resolvers are not defined. So what we can do is copy in the type defs and resolver for the basic project that we already made in the first video. So I will just copy that in here, so we'll put it above, and I will go through what we are doing here. This GQL function here in front of the backtick is actually takes the content of the string that we type out here and calls this function on a string. So it is basically like sending a string into a function, so it's no magic. You see the type here of department. It is basically the same that we did in the definition of department schema here in Mongo. So it's based on JavaScript. If you put the exclamation mark here, it means that this is a not null parameter, so it must be defined. We have the employee here, and the difference in the employee is that instead of having this object here, we can just say that we are referring to department here, because GraphQL type defs, the language there understands these objects that you have already defined, and same with company. All the employees is just array of employee. So that's quite simple, but the problem and the goal of this video is to show how to get rid of this this duplication of work to define all the models and schema in one file and then have to type it all out. It's a lot of work, and we want to skip it because we have already defined the models here. The resolvers or the query comes here. Here we have, you see that the type query is a special taken word in GraphQL. So here we define all our queries. One of them is all companies and returns array of company. So the resolvers are just objects, and they have to match the query object and mutation have to match with what we define in the type defs. So we have here all companies, and then we have a resolver for exactly that query here. And that is just an async method that will copy paste the command that I have here, await command. So it will just do exactly the same as in the first video. Get all the companies, populate the employees, and then populate the departments of each employee. Then we should be able to run our app. If I save this here and try once more. No. So we have an error again. Address is in use. Okay. Then we can just change the address to 3050, I think. And try once more. Get another error, port is not defined. Yeah, port is here, right? So we'll just do it like this and see if that helps. Yeah. Then we see server is ready at this endpoint and the WebSockets is ready on this endpoint. So we can just copy this one or control click on it and open the link in the browser. And what we get here is the GraphQL interface. This is provided by the Apollo server, so Apollo server does all the heavy work for us. I will just show you some simple things. We have tabs up here. We can have as many queries and mutations as we want. We can, here it automatically generates the schema for us. This is built-in cache control that we have access to, and then we have access to company, department, and employee, just as we defined it in the type def. It also provides some documentation of queries and mutations, so it shows you which parameter you have defined in the type def for all companies query. So then you can just hit the Q key, and then comes with an autocomplete for us here, and if I press Ctrl space, it shows me all the queries that are available. I will select the one we have, and here you can select the fields you want to show. So I will take employees also, and in the employees I will show first name, and then I will show the department, and in the department I will show name. So we'll try to run this query now, and we get our big company. And the good thing with GraphQL, you can specify exactly what fields you need and how deep you need to go. If we only need the name of all companies we have, we can just do it like this. So this saves a lot of network traffic when we are, as an example, developing a mobile app that only needs the name. So in some REST or most of the REST APIs available today, it will return you with all the fields in the company REST endpoint, but here we can define it, which is cool. So the last thing we need to do is to replace the definition of type defs and resolvers with GraphQL-compose, because it's too much job to type all these definitions again, all the input definitions and all the mutation, etc. If you have 50 collections in an application, it takes a lot of time to maintain it in two places. Simple. So what we'll do, we will remove the type defs from here, and we will remove our good resolver here. So now we only have the Apollo server running here, and we have department, employee, and company here. So if I switch to GraphQL-compose, it is an imperative tool. It provides methods for creating types and GraphQL models for further building of complex relations in your schema. So luckily enough, we have Mongoose here also, so they support Mongoose right out of the box. So what we need to do is to add this to our project. So we will do that. Shut down the project and add this to our package.json file. And when it is done, we will start doing this automatically from our models. So if we look at the documentation, they have different libraries for different versions of Node, and one with float type declarations. I will just use this for Node 8 since I'm using Node 10, so it's the support async and await. And here we see an example with a schema, and here you see with this code here, we basically get all the finds, all the filtering, all the sorting, pagination. We can create, update and remove, etc. So they say here that if you think that's much code, internally they create about 55 GraphQL types. So if we would do this by hand, it will be much more code that we need to implement. So we will just do it like they had defined in the example. First we have to create the company TC with compose with mongoose. So we need to take that into our application. So I will just import it here. So here we have compose with mongoose, which will compose the TC and the schema composer, which we use to create the schema. We will start with the company, and then we will, I have, to save some time, I tested this out before. So I will just paste it in here and go through it. So we get the TC here, and we use the at fields. So basically we are defining queries for company here. So we will have here company by ID, company many, etc. that use the built-in mongoose methods. And also here we get create, update and remove, which uses also the mongoose methods here internally. But so instead of doing all these resolvers, the compose does this for us. So the only thing that is left is to add this to build the schema basically. So here, and so instead of importing type defs and resolvers that we had before, we will just take in the total schema, which is already built for us here. So let's try this out. See if we get any errors. We don't get any errors, so we will just go into our playground and refresh by hitting this button here, and then we should, yeah, I didn't refresh it, so I will just refresh the page. So now we have in our schema, we have all this code automatically done for us with all the filter methods that comes available, all the input types, etc. And so we see now we can do queries by ID, by many, etc. So if I delete this one, hit the tab button and control space, I suddenly have much more queries available. And if I go in here, I have name of my company, I have my employees, and if I run it here, it doesn't auto-generate the relation, so we have to add that to our code also. That is something that I think will come. I think it's rather strange that they don't pick up the relations and do this automatically for us, but yeah. So I will also, after we have done this for the company, we will add the TC for employee and department. So we have that available here. I didn't specify the methods here because it will just be the same. So just to show you how we add relations for this, guys, we can start with department, or no, maybe it's better to start with the employees because it comes first. So we will have here company TC. We will add the relation, so when it sees the employees field, it will resolve it by getting the resolver find by IDs from the employee TC. And this method takes IDs as a parameter, and that it will pick up from the employees. So all these IDs will be picked up, and we will project in the employees field. We will set that to true, so we will get the employees field by this resolver here. So let's try that out, see what happens. So if I refresh the page, go here, and now I should be able to get first name, last name, etc., department. And we see here we get the apartment ID, so we do the similar thing to get in the department. So we will just do similar relationship here, but then we use the department TC, find by ID, it's not IDs, so it's only one ID, one department, and then it is without S here also, but very similar to, the code is very similar. Save this one, go back here, refresh, and now I should be able to get the field for my department name, etc. So now we got all the necessary parts of our company TC. So the last thing I will do is to remove this schema composer query that is specified for the company TC and remove it here. And I made the function to do this a little bit more general. So I create the function called add to schema, which takes in the name of the collection and adds all the necessary queries that you want and the resolvers that you want. I just limited it here so not to take all available. And then I can just loop through all the schemas, get all the models from Mongoose, and just call add schema for all the models that we have in our Mongoose database. So let's try this out and see what happens. Okay, here we have here I need to take in Mongoose because I call it directly here. So we'll just get it from Mongo and put it here. Save this once more, see what happens. It's running. We refresh our page here, our playground, and now we should see all better in documentation. Now we have everything for employee, everything for company and department. So if I add a new model to my schema, it will automatically come into GraphQL because this loop here loops through all the models in my Mongoose definition. So this is the end for now, and I hope you learned something about Mongoose and GraphQL and automatic generations of schema.